CCNA 4 Connecting Networks, Chapter number 3 Point-to-Point Connections. In these chapters, we are going to discuss about serial and point-to-point connections, how does the PPP operation, how to configure the point-to-point protocol, and troubleshooting the WAN connectivity. The main objectives of this lesson are the fundamentals of point-to-point serial communication across a WAN, how to configure a HDLC encapsulation on a point-to-point serial link, what are the benefits of using the PPP over HDLC in a WAN, how does the PPP layered architecture and the functions of LCP and NCP, how a PPP session is established, how to configure the point-to-point encapsulation on a point-to-point serial link, how to configure a PPP authentication protocols, and how to debug and troubleshoot the point-to-point protocol. Serial point-to-point overview. There are two different types of connections, serial and parallel, or serial and parallel ports. A point-to-point connections are used to connect LANs to the service provider WAN, which is also referred to as a serial connection or a leased connection. Communication across a serial connection is a method of data transmission in which the bits are transmitted sequentially over a single channel. In a parallel communications, bits can be transmitted simultaneously over a multiple wires. On the WAN link, the data is encapsulated by the protocol used by the sending router. This encapsulated frame is sent on a physical medium to the wide area network, and on the receiving end, the receiving router uses the same communication protocol to de-encapsulate the frame when it arrives. This is how the serial communication took place between a sending router and a receiving router. Basically, three serial communication standards between local area network to wide area network are RS-232, V.35, and HSSI. Point-to-point communication links. Point-to-point links can connect two geographically distant sites. For example, a company is having the two different branches, so we can apply a point-to-point connection to link them together. Point-to-point connections are carrier dedicates specific resources for a line leased by the customer as a lease line connection, and point-to-point links are usually more expensive than the shared services. Time division multiplexing. A multiplexing is a scheme that allows multiple logical signals to share a single physical channel. TDM, or a time division multiplexing, shares the available transmission time on a medium by assigning the time slots to users. The MUX accepts the input from attached devices in an alternate sequence, which is known as round robin, and transmits the data in a current pattern. T1 and E1 and ISDN telephone lines are the common examples of synchronous time division multiplexing. We have statistical time division multiplexing, or STDM. Statistical time division multiplexing uses a variable time length slot, which allowing channels to compete for any free slot space. Statistical time division multiplexing does not waste the high-speed line time with inactive channels using this scheme. Time division multiplexing examples. The industry uses the SONET, which stands for Synchronous Optical Network, or Synchronous Digital Hierarchy SDH, standard for optical transport of TDM data. Traffic arriving at the SONET multiplexer from the places at 2.5 gigabits per second goes out as a single stream at 4 multiplied by 2.5 gigabit per second, or which is equivalent to 10 gigabits per second. Demarcation point. Demarcation marks the point where your network interfaces with a network that is owned by another organization. For example, the connection from your home to your company's telecom provider. It is an interface between the CPE, which is a customer premises equipment, and a network service provider equipment. Point in the network where demarcation point is in the network where the responsibility of the service provider ends. DTE and DCE. DTE, which is commonly known as customer premises equipment, generally a router. It could also be a terminal, computer, printer, or fax machine if they connect directly to the service provider network. DCE, which is commonly a modem or channel service unit slash data service unit, or CSU DSU. It is a device which is used to convert the user data from the DTE into a form acceptable to the WAN service provider transmission link. The signal is received at the remote DCE, which decodes the signal back into the sequence of bits, and the remote DCE then signals this sequence to the remote DTE. DTE is a data terminal equipment. In short, it is the end of the user's device on the WAN link. And DCE is a data communication equipment, which is basically the end device and a WAN provider's side of the communication facility and responsible for providing the clocking signal. These are some of the serial cables. We have two parts, as we discussed before, DTE and DCE. So when we are using a serial connections between LAN and WAN, we have to make one end of the connection as DTE and another end of the connection as DCE. Serial bandwidth. Bandwidth refers to the rate at which the data is transferred over a communication link. We have different type of carrier transmission rates which supports different line types, and these different line types supports different bit rate capacity. For example, 56 line type 56, 64, T1, E1. So according to their capacity, they are supporting a different type of bit rates. WAN encapsulation protocol, such as HDLC encapsulation, in which the data is encapsulated into frames before crossing the WAN link. An appropriate layer 2 encapsulation type must be configured. We have a different WAN encapsulation protocols. When we are using a lease line, we have HDLC, PPP, and SLIP. When we have a circuit switching through the telephone company, we can have a packet switching through a telecom provider, and then we can use X.25 frame relay and asynchronous transfer mode. HDLC encapsulation. It is a bit-oriented synchronous data link layer protocol which is developed by the International Organization for Standardizations, or ISO. It uses synchronous serial transmission to provide error-free communication between 2 points. It defines a layer 2 framing structure that allow for flow control and error control through the use of acknowledgements. Cisco has developed an extension to the HLDC protocol to solve the inability to provide multi-protocol support, and the Cisco's HLDC, also referred as CHDLC. HDLC frame types. There are different fields in a HDLC frame. The flag field initiates and terminates the error checking, and the frame always start and ends with an 8-bit flag field started with 0, 1, 1, 1, 1, 1, 1, and 0. Iframes carry the upper layer information and some control information, sends and receives sequence number, and the pool final bit performs flow and error control. The S frame or supervisory frame provides control information requests and suspend the transmission report on status and acknowledge receipt of information frame or iframe. The U frame is an unnamed frame format which supports the control purposes and are not sequenced. How to configure the HDLC encapsulation? Default encapsulation method used by the Cisco devices on a synchronous serial lines, point-to-point protocol on lease lines between two Cisco devices, and when we are connecting to a non-Cisco device using a synchronous point-to-point. The basic commands on a router where we would like to configure HDLC: global configuration mode, interface is serial 0/0/0, and in an interface where we would like to configure by giving the command encapsulation HDLC. This above command enable the HDLC encapsulation, and HDLC is the default encapsulation on synchronous serial interfaces. Once we configured the HDLC, sometimes there are problems, so we can troubleshoot HDLC interfaces or troubleshooting a serial interfaces by giving a command show interface serial to the specific port or to the specific interface, which is in this example show interface serial 0/0/0, and you can see here the serial /0/0/0 is up, line protocol is up, and encapsulation is HDLC. At the same time, we can give another command which is called show controller serial, which is basically going to show us the end router is DTE or DCE. If it is DCE, we must have to configure the clock rate as well. Troubleshooting a serial interface, we have different type of status of the serial line, and we can apply the possible condition and the problems and solutions. So sometime the serial X is down, line protocol is down, which is a DTE mode. The possible condition, the router is not sensing a carrier detect signal, which means that CD is not active. The possible solution is check the LED on the CSU DSU to see whether the CD is active, or insert a breakout box on the line to check the CD signal. Similarly, according to the scenario, we can apply the different troubleshooting tools and their solutions. Sometime the status line gives the error message serial X is up, line protocol is down, which is the DCE mode. So the possible condition, the clock rate interface configuration command is missing. So we have to add the clock rate interface configuration command on the serial interface. Further to that, sometime the status line gives the error message is serial X is up, line protocol is up, but looped. A possible condition, a loop exists in the circuit. The sequence number in the keep alive packet changes to a random number when a loop is initially detected. If the same random number is returned over the link, a loop exists. So the possible solution, we can go to the configuration mode and we can use the command show running config in a privilege execution command to look for any loopback interfaces configuration command entries. If there is a loopback interface configuration command entry, we can use the no loopback interface configuration command to remove the loop. Similarly, we can apply a different type of troubleshooting, depends according to the scenario and depends on the error. Point-to-point protocol operation. Introducing point-to-point protocol. Point-to-point protocol or PPP contains the three main components. The first one is HDLC protocol for encapsulating the datagrams over point-to-point links. Extensible Link Control Protocol or LCP is used to establish, configure and test the data link connection. The family of Network Control Protocol NCP to establish and configure different network layer protocols such as IP version 4, IPv6, AppleTalk, Novel IPX and SNA control protocol. What are the advantages of point-to-point protocol? The first advantage is point-to-point protocol is not proprietary. Point-to-point protocol includes many features which is not available in HDLC. Link quality management feature monitors the quality of the link. If too many errors are detected, point-to-point protocol takes down the link, and amazingly it supports PAP and CHAP authentication. PAP is a password authentication protocol and CHAP is a challenge handshake authentication protocol. Point-to-point protocol in a layered architecture. LCP sets up the point-to-point connection and its initialization parameters. NCP handles the higher layer protocol configurations and LCP terminates the PPP connection. At the physical layer, the point-to-point protocol can use synchronous physical media such as lease line services, asynchronous physical media such as those that use basic telephone service for modem dial-up connections. Point-to-point control protocol LCP. The LCP provides automatic configuration of the interfaces at each end, including handling varying limit on packet size, detecting common misconfiguration errors, terminate the link and determine when a link is functioning properly or when it is failing. Point-to-point protocol uses LCP to offer service options. These service options are primarily used for negotiation and frame checking when implementing the point-to-point controls specified by an administrator. Point-to-point protocol network control protocol NCP. PPP permits multiple network layer protocols to operate on the same communication link. For every network layer protocol used, PPP uses a separate NCP. PPP uses NCP to negotiate the layer 3 protocol that will be used to carry data packets. They provide functional fields containing standardized codes to indicate the network layer protocol type that PPP encapsulates. This is a structure of PPP frame. We have flag field, address field, control field, protocol field, data, frame check sequence or FCS, and the frame terminates with the flag field. Establishing a point-to-point protocol session. Phase 1. LCP must first open the connection and negotiate the configuration options. It completes when the receiving router sends the configuration acknowledgement frame back to the router who initiating the connection. This is called phase 1 link establishment. Phase 2. LCP tests the link to determine whether the link quality is sufficient to bring up network layer protocol. So in phase 2, LCP determines link quality, and it may be we should discuss some details about quality or maybe not. Phase 3. Network protocol negotiation. After the LCP has finished the link quality determination phase, the appropriate NCP can separately configure the network layer protocols and bring them up and take them down at any time. LCP operation. LCP operation includes provisions for link establishment, link maintenance, and link termination. LCP operation uses 3 classes of LCP frames to accomplish the work of each of the LCP phases. The first phase is a link establishment frame which establish and configure a link. In this phase, LCP configure request, configure acknowledgement, configure NAC, and configure reject. The second phase is a link maintenance frame manage and debug a link in which code reject, protocol reject, echo request, echo reply, and discarded requests has been configured. The final phase of the LCP operation is a link termination frames which terminates a link, terminate a request, and terminate acknowledgement has been passed at this stage. During the link maintenance, LCP can use message to provide feedback and test the link. Echo request, echo reply, and discard request can be used to test the link. Code reject and protocol reject provides feedback when one device receives an invalid frame due to either an unrecognized LCP code, which is LCP frame type, or a bad protocol identifier. This is how the LCP operation initiates between two devices they would like to communicate using the point-to-point protocol. The connection initiates with the LCP configure request. Then in turn the LCP configure acknowledgement completes the session. So NCP configuration is done. And in the second stage is the LCP maintenance, echo request, then echo reply, and then between sending and receiving devices the data exchange depend on the code. If the code is reject, the finally LCP termination, LCP terminate the connection request, and then LCP terminate acknowledgement. This is a structure of LCP packet. Field length is in bytes. These are some of the LCP packet types and their codes. Code 1 related to configure request, code 2 is configure acknowledgement, code 3 is configure NAC, code 4 configure reject, code 5 terminate request, and code 6 terminate acknowledgement. Code 7 code reject, LCP code 8 protocol reject, LCP code 9 echo request, LCP code 10 echo reply, and LCP code 11 discard request. PPP configuration options. These are some of the optional functions which is included. Providing the authentication using either the password authentication protocol PAP or challenge handshake authentication protocol, which is known as CHAP. Compression using either stacker or predictor. Multiple link that combines two or more channels to increase the WAN bandwidth. This is how the NCP operates between sending and receiving devices. How to configure point-to-point protocol. These are some of the configuration options such as authentication. So two authentication choices are password authentication protocol PAP and challenge handshake authentication protocol, which is CHAP. Compression basically increases the effective throughput on PPP connections by reducing the amount of data in the frame that must travel across the link. The protocol decompresses the frame at its destination. Two compression protocols available in Cisco routers are stacker and predictor. Error detection. This identifies the fault conditions. The quality and magic number options help to ensure a reliable loop-free data link. The magic number fields help in detecting links that are in a looped back condition. Magic numbers are generated randomly at each end of the connection. PPP callback. PPP callback is used to enhance security. With this LCP option, a Cisco router can act as a callback client or a callback server. The client makes the initial call, requests that the server call it back, and terminates its initial call. The callback router answers the initial call and makes the return call to the client based on its configuration statement. The command is PPP callback, and then we have two arguments to accept and request. Multi-link is the alternative which provides load balancing over the router interfaces that PPP uses. Multi-link PPP provides a method for spreading traffic across multiple physical WAN links while providing packet fragmentation and reassembly. Proper sequencing, multi-vendor interoperability, and load balancing on inbound and outbound traffic. PPP basic configuration commands. On router 1, interface serial 0/0/0 encapsulation PPP. On router 2, interface serial 0/0/0 with the proper IP address and then encapsulation PPP. PPP compression commands. On both routers, we can use the command encapsulation PPP and then compress predictor. Similarly, on the second router, we have to give the command encapsulation PPP and compress predictor. In our interface mode, when you type compress, we have two options. One is predictor and one is stacker. Predictor is basically an optional command which specifies that the predictor compression algorithm will be used. Stacker is also an optional command which specifies that the stacker LZS compression algorithm will be used. PPP link quality monitoring command. The PPP quality percentage command ensures that the link meets the quality requirement set, otherwise the link closes down. PPP quality 80 on router 1 and PPP quality 80. 80 is basically a percentage which specifies the link quality threshold, and this range is between 1 to 100. Configuring the multi-link commands on point-to-point protocol. In this example on router number 3, we have given a command PPP multi-link and then add the multi-link command PPP multi-link into group 1. Similarly, on a router 4, we have issued the command PPP multi-link and PPP multi-link group 1. So both on sending and receiving routers, once they configured the multi-link, it must be in a same group. Verifying the point-to-point configurations. We have three basic commands to verify the point-to-point protocol. The first command is a show interfaces. This displays statistics for all interfaces configured on the router. Show interface serial displays the information about a serial interface, and show PPP multi-link. This command displays the information about a PPP multi-link interface. Further to that, the output indicates the interface multi-link 1. If we issue the command show PPP multi-link, the host name of both the local and the remote endpoints and the serial interfaces assigned to the multi-link bundle. As we can see it in this example, we have a remote endpoint discriminator 1, router 4, and the local endpoint discriminator, router 3. Member links are 2, which are in active state. An interface configured is SE0/1/1 and SE0/1/0. Point-to-point authentication protocols. We have password authentication protocol known as PAP and challenge handshake authentication protocol which is known as CHAP. Initiating the PAP, router 1 sends its PAP username and password to router 3, and router 3, once he receives this information, evaluates the router 1 username and password against its local database. If it matches, it accepts the connection. If not, it rejects the connection. This is a simple process. It's a two-way handshake between the two routers. In a challenge handshake authentication protocol, it's a three-way handshake process. Initially, in this example, router number 3 initiates the three-way handshake and sends a challenge message to router 1. Router 1 responds to router 3's challenge handshake authentication protocol challenge by sending its CHAP username and a hash value that is based on the CHAP password. Once router 3 receives the response, the connection will be established. Using the username and password for router 1 in its local database, router 3 compares its calculated hash value with the one sent from router 1, and then he can accept or rejects the connection. And this is the flowchart how the PPP encapsulation and authentication process took place. Configuring the PPP authentication command. The basic command is PPP authentication with a variety of options. We can use simple CHAP, we can use the CHAP with PAP or PAP with CHAP or PAP. If needed, CHAP enables the CHAP on a serial interface and PAP enables the PAP on the serial interface. CHAP and PAP both could be used together and performs CHAP authentication before the PAP. Similarly, PAP and CHAP combination, this enables both CHAP and PAP authentication and performs PAP authentication first before the CHAP. And then we have some additional optional options. Configuring PPP authentication. On router 1, we configured username router 2, password someone, PPP authentication PAP, and PAP sent username router 1 password someone. Similarly, on the router number 2, we have to configure the PPP authentication PAP, because on router 1 we have configured PAP authentication. So it can't be on one router you configure PAP and another router you configure CHAP. In the second example, we have configured the CHAP authentication on both routers. As you can see, PPP authentication CHAP. Similarly, on the other router, we have to configure PPP authentication CHAP. Troubleshooting WAN connectivity. Troubleshooting the point-to-point serial encapsulation, we have different parameters which you can use it with the PPP command. These are, first we have to issue debug point-to-point protocol, and then we can use different parameters such as packet, negotiation, error, authentication, compression, and CBCP. This is how we have to give a troubleshooting command on a router configured a PPP with PPP authentication. Debug PPP authentication, and you can read the various messages which is going to give you the complete information whether the password is configured proper or the router 2 is unable to validate the CHAP response due to any reason. So what we have learned in this chapter, we talked about point-to-point links, which are usually more expensive than shared services. However, the benefits may outweigh the costs. Constant availability is important for some protocols such as voice over IP. SONET is an optical network standard that uses the statistical time division multiplexing for efficient use of bandwidth. The demarcation point is a point in the network where the responsibility of the service provider ends and the responsibility of the customer begins. The customer premises equipment, or CPE, usually is a router, and it is a DTE device, and the DCE is usually a modem or CSU DSU. Cisco HDLC is a bit-oriented synchronous data link protocol, which is extension of HDLC, and it is used by many vendors to provide multi-protocol support. This is the default encapsulation method used on Cisco synchronous serial lines. Synchronous point-to-point protocol is used to connect two non-Cisco devices to monitor link quality, provide authentication, or bundle links for shared use. LCP is the PPP protocol used to establish, configure, test, and terminate the data link connection. LCP can optionally authenticate a peer using PAP or CHAP. Thank you for watching.